Okay, this was a little puzzle that I was looking at on another thread. This is the formula for monthly payments, which we're trying to solve an equation on and work out whether a TVM solver is better for that. In this case, we're calculating the periodic payments from value at the beginning, periodic interest rate, that's periodic interest rate again, and then n, which is the number of payments. And this is a bit of an extreme example. So present value is equal to 300,000, 101 and 72 cents or dollars or whatever. And then the interest rate, so n is the number of seconds in a year, 60 times 60 times 24 times 365, and then the interest rate over the year is 10%, and so the periodic interest rate is 0.1 divided by n. Okay, so I was trying to solve this actually on quite a few algebraics, just using the formula. So let's have a look here. Classic graph print style one. Right, so let's start with 300, 101.72. I'm going to times it, and then I'm going to use the fraction button. And in the top, let's get the interest rate in there. So the interest rate is going to be 0.1 divided by, and then bracket 60 times 60 times 24 times 365, close brackets. And then in the bottom, it's going to be 1 minus brackets, and then 1 plus. And then we need the interest rate again. And the interest rate is 0.1 divided by n, which is 60 times 60 times 24 times 365. Right, now 1 plus the interest rate needs to be to the power of minus n. So actually, it's quite hard to tell from this point how many brackets after I need to put the power. So it needs to be everything up to here. So everything within this bracket onwards. So it's 1, 2, 3. So we need 3 after that. So it's 1 there, 2, 3. Power. There's power there. And then we need n, 60 times 60 times 24 times 365. But we need negative n. So that is, there we are. Right, hopefully that will work. There we go, and that's pretty much, so it's about 0.01 or 1 cent, but not quite. And that's actually a very accurate answer there. Right, so an RPN, so this is a bit tricky on just a 4-level stack, but it is doable. It's much easier on a infinite stack. So we've got present value, so we need the interest rate, so it's going to be 0.1 divided by 60 times 60 times 365 times 24. That's that number there. And now I know I need to use n and the interest rate later, so I'm going to push it up the stack and roll it down, so I popped it at the top there. If I divide 0.1 by this, that's going to give me the interest rate. That's again something else that I'm going to need again. So I'm going to divide that, but I'm going to give myself an extra one. Right, now then, so we've got all the stuff that we need on here. Now this here is the present value, this is the interest rate, so I'm just going to times that because that's part of the formula. And we've got this value here. And now what I need, I actually need I need the interest rate, but so this does take a little bit of thought, but let me swap those round and pop that down here. There we go. So now I've got this part. This is part of the calculation. I've got the interest rate here. I've got n here. So let's start then. So at the bottom of the formula, we've got the interest rate. We're going to add 1 to it. There we are. We now need to raise it to the power of n. So I'm going to bring n down next to it. So there we've got n, so let's swap that around. It's negative n, and then raise that to the power. And then we're going to 1 minus that. So 1, swap them around, hit minus, and we're going to divide. And that gives us our answer there, which is almost exactly the same. So I don't know, I mean, I think that's not too hard on RPN, and actually the issue with algebraic is that, I mean, how can I review this? You kind of, sometimes things are so long that, you know, there's 3 brackets there, trying to work out what they cover is tricky. So I don't know, I think in this case there's not much of an advantage to using an algebraic, even if you can review it.